Okay, so let's get started. So 1 has a negative y-intercept. Oops. Negative. The slope is negative, so the slope is 1 over 1. So it's going to up just to a few points. Enough points for me to create a line. And this, I saw someone doing that just to the side to remind them that both of them are going to be solid lines. So first one. So I like when you guys stretch that line out like that. Don't make it a short line. We want the area above or below, including the points on the line. Well, try 0, 0, plug 0, 0 in the first inequality. So you get 0 less than negative 2. Is that true? No. So we don't want this area where 0, 0 is. Rather, we want the other area. So that's what I'm going to show you. So every point in this area, including the points on the line, make that first inequality true. Then I'm going to take the second inequality. Y-intercept is 2. Oops. It's the slope is negative 5 over 1, so I can't go up. I can, but I don't have room, so I'm going to go down 1, 2, 3, 4, 5, and then I'm going to go 1 to the right because it's also negative slope, so when I connect the dots, it has to come down. So it has to be like that. Okay. Let me just move it a little bit. Okay. So now focus on that line. Let me just lower this right here. And do I want areas to the right of that line or under that line? Let's see. Well, if I plug 0, 0 there, I get 0 greater or equal to 2, which is not true. So I don't want where 0, 0 is. I want the area on the other side of 0, 0, which is not on the other side of 0, 0, but on the other side of the line, which is this one, where 0, 0 is not present. Okay. So, and again, the blue and blue only area satisfies the first inequality. Red and red only area satisfies the second equality, but the areas where the red and blue meet, that's a solution to both inequalities. And I'll put a big S here. You should check, because when you get your quiz, I'm going to ask you to check. Pick a point in that area. I'm going to pick, let's see, negative 1, 2, 4, and 6. I'm going to pick 4 and negative 7, which is about here. Right, it's in that solution area. So if I plug it into the first inequality, I get negative 7 less or equal to negative 4 minus 2, negative 7 less or equal to negative 6. Check. If I plug it into the second inequality, I get negative 7 greater or equal to negative 5 times 4 plus 2, negative 7 greater or equal to, and that's negative 20 plus 2, negative 7 greater or equal to negative 18. Negative 7 is definitely greater or equal to negative 18. Check. Let's do 4. Nice, let's go 4. 4 is a little simpler. Right, so let's do the first one. So I know this is going to be a solid line, this is going to be a dashed line. I don't know if that helps you or not. So the first one, x is less or equal to negative 3, is undefined slope or no slope. So when it's undefined slope is a vertical line, and this is going to be a solid. So let's go, and there you go. So I want the side where the x values are less than negative 3, and that side is definitely this side. Everything here, if you pick any point here, the x value is going to be less than negative 3. Okay, so neatness matters. Try to be neat. Second inequality, y is less than 5 over 3x plus 2, dashed line, and we're going to do positive 2. There's my y-intercept. It's a positive slope. Changing y is 5, changing x is 3, so it's 5 up and down and 3 left and right. So let's go down 1, 2, 3, 4, 5, and we're going to go 1, 2, 3 to the left, because when I connect the dots, I want to make sure that this is a positive slope. So I get something like this. Oops. All right. I'll adjust the line. I don't know why it does that. Okay. So now I have to shade the area above the line or below the line. So pick 0, 0, we can. right? 0, 0 is not on the line, so it's a point that I can select. If I plug it in, I get 0 less than 5 over 3 over 5 over 3. Plus 2, and 0 plus 2 is 2. Is 0 less than 2? It is. So I want the area. 0, 0 is on this side of that line, so I want everything on this side. Right? So again, anything, the area that I'm shading in red only, okay, it's going to be the solution for the second, and the black only is going to be for the solution for the first inequality, but this area where the red and the black meet, okay, and I'm going to extend my y-axis over here a little bit lower. Right, I'm going to shade so that you can see. So that area there, and I hope you can see it, this is my solution. Any point in that area satisfies both inequalities. And let's pick a point here. Let's pick -5, and let's go to negative 5, and I can pretend I can go down -5 and -9. I don't know. I'll pick -5, -9, which is hopefully somewhere around here. If I plug it into the first equation, I get -5 less or equal to -3. Check, right? The first inequality. The second inequality, if I plug it in here in the second inequality, the y value is -9, less or equal to 5 over 3 times -5 plus 2. -9, well, what is that? 5 over 3 times, so let me do that over here on the side. Should pick an easier number. -25 over 3 plus 2. This is -8 1/4 plus 2, which is going to give me a total of -6 1/4. Sorry, 1/3. All right, so, and if I subtract, I get -6 1/3. You obviously might have a different number because you picked a different point in that area, so that's fine as long as it works. So my test using -5 and -9 worked for the first inequality as well as works for the second inequality, because -9 is definitely less than -6 1/3. I forgot what's next. 7 and 8. Okay. These are fun to do. I mean, I really like this topic. But I promise you'll see this next year a lot. 7 and 8. So let's do 7. 7 I have to make a little adjustment. So let me write that over here. 4x plus y less than 2 minus 4x on both sides. And I get y less than -4x plus 2. So I cross that out. And I write y less than -4x plus 2. Let's graph that. Y-intercept is 2. My slope is 4, and let's put a 1 there. 4 over 1. So 1, 2, 3, 4. And I'm going to go right, because when I connect the dots, it has to be a negative slope, so we're going to go down. And that is a dashed line. Where's my dashed line? Okay. Maybe I should change colors. Put blue. 1 dot. 2, 3, 4. There. And we'll label that -4x plus 2. Do we want this side or we want this side of the line? So left side or right side of the line. This is less than. So if I pick 0, 0, so if I pick 0, 0, I get 0 less than 2. Is that true? Yes, it is. So I know because 0, 0 work, it means that everything on this side where 0, 0 also resides works. So all these points on this side of the line, except the points on the line, make that inequality true. And the second thing we're going to graph is y greater than -2. So this one is one with zero slope, right? So it's going to be a horizontal line. So let's find y equals greater. Y is -2. So here's my y-intercept, -2. This is going to be, again, a dashed line. And I hope you understand what I mean by neatness now. There you go. Put it down in red. Y greater than -2. So where is y greater? Where are the points where the y is greater than -2? Is that above the line or below the line? Well, greater than -2 has to be above the line. So all these make the second inequality true. So, but the area where the blue and the red intersect makes both inequality true. So let me put a big S here. No, different S. Okay, so oops, let me choose a different. All right, there we go. That's my area. Pick a number over there. I would definitely pick an easier one. Is 0, 0 in there? Well, let's see. 0, 0 is in there, so anytime I can pick 0, 0, I'll use it. So if I pick 0, 0, it should work for both inequalities. So the first inequality is y less than -4x plus 2. If I plug in 0, 0, I get that, and that works for the first inequality. The second inequality is y greater than -2. So if I pick again 0, right? Remember, we're substituting this value for 0 for y and this value for x. So in this case, y is 0 greater than -2. That's also true. So we are good. Last problem. Ugh. So the last problem, you have to rework both inequalities, right? So to write into point intercept form. So let's do the first one. So the first one, it looks 3x plus 2y greater or equal to -2. Sorry, I forgot the y. So let's do minus 3x on both sides. That goes away. We're left with 2y greater or equal to -3x minus 2. Divide everything by 2. Those 2 goes away, and I get y greater to -3 over 2x minus 1. So let me cross that out. I'm going to write y greater or equal to -3 over 2x minus 1, and this is going to be a solid line. Erase. Second inequality, pick blue, x plus 2y less or equal to 2. We're going to subtract x from both sides. We get 2y less or equal to -x plus 2. Divide everything by 2. We get y less or equal to, and I'm going to put a 1 there, -1 over 2x plus 1. That's my second inequality. Y less or equal to -1 over 2x plus 1. And it's also going to be a solid line. That's why I put that line there. Okay. All right, let's graph the first one in orange. Y-intercept is -1. It's a negative slope, so it's going to come down. So it's changing y is 3, and changing x is 2. So 1, 2, 3. I'm going to go right too. I'm going right because when I connect these dots, it has to be a negative. And it's going to be a solid line for both. Okay, so let's move that line a little bit. All right, that's better. Give it a name. And then we got to shade the area above that line, below that line. It's greater than. So I'll tell you it's going to be above the line without testing, but let's test 0, 0. So if I plug 0 and 0 for x and y, I get 0 greater or equal to -1, which is definitely true. So the area that we want to shade is the one above the line. Right. In blue, let's do the second line. The y-intercept is 1, positive 1, so I'm going to put a blue dot right there. It's again another negative slope, so it's going to go down. So the slope is changing y is 1, changing x is 2, so 1 and 2. So 1 up and down, and 2 left and right. So up and down. So let's go down 1, which means left and right I'm going to go 2. 1 down, 2 right, or 1 up, 2 left, 1 up, 2 left. Those are some of the points. This is going to be a solid line. Okay, just arrange that a little better. Okay, hang on a second. Just a little better. Okay, and now do I want the area above this line or below this line? Just pick 0, 0, see if it works. Oh, sorry, let me give it a name. Y less or equal to negative half x plus 1. If I do 0, 0, 0 for y and 0 for x, I get 0 is less or equal to 1, and that is definitely true. So if that's true, I want the area below this line, because that's where 0, 0 is, below that line. So again, where the orange and blue meet, points in there, including the lines, the points on top of the line, will satisfy both inequalities. So pick a number in there, or pick a value in there, just to test it out, to check. And 0, 0 is definitely in there, so we're going to use the point 0, 0. Thank God. So I'm going to go to my first inequality. Let me use orange. So my first inequality, I get 0 greater or equal to negative 1 if I substitute, right? So here's my inequality. If I plug in 0 and 0 for x and y, I get that. The second inequality, here's my, let me write the inequality. Y less or equal to negative 1 half x plus 1. If I substitute 0, I get this, which is also true. So it proved that the points in that area where the orange and blue intersect work. Yeah, that's it.